Meet AeroGuard, the next generation of wearable gas detection technology engineered to protect workers from high-risk environments like mines, oil refineries, and industrial facilities. What do they all have in common? An invisible enemy. Gases such as carbon monoxide, carbon dioxide, methane, and even oxygen. Gases that at a moment's notice can change a situation from hazardous to disastrous. AeroGuard is here to fix that. This is the device. It's supported by an ESP32 microcontroller and powered by 4 AA batteries, measuring up to 6 volts and 2000 milliamp hours of capacity. The device has 4 main gas sensors: the oxygen sensor, the methane sensor, the carbon monoxide sensor, and the carbon dioxide sensor. Their values are being processed and then displayed onto this OLED, which allow you to view values in real time. There's an onboard LED and a buzzer for a combination of audible and visible alerts, as well as an SD card underneath for local data logging. Additionally, the ESP32's built-in Wi-Fi connectivity allows for seamless data sharing for team-wide awareness via the Lassonde dashboard. The best part? The straps, which make the device wearable and usable in many different work environments. In terms of the concept development, we had originally gone with our first alternative, which consisted of duty cycling and sleep mode, modular sensors, contextual alerts, and a USB interface. The disadvantages being that it was limited in interfacing due to only being USB. It possibly might have calibration issues or be slower at reading because of the extended sleeping, so we decided to go with this alternative that consisted of sleep mode and MOSFET switching, a built-in sensor array, multimodal alerts, and an SD interface and the Lassonde dashboard. Advantages being that the sleep mode with the MOSFET switching reduced the power as much as possible for some of the very power consumptive sensors. The multimodal outputs, that being the visible LEDs, the audible buzzer, and also the visible OLED, boosted awareness to the max, with the built-in sensor array being a little simpler to design and implement, and the SD card allowing for offline data logging. Disadvantages, it wasn't modular, and not being modular lowers the replacement and repair cost, and the SD interface might not be as practical or accessible as a USB interface might be. In terms of the final block diagram, as you can see that there's a power block that powers the ESP32 with a 5-volt buck converter, steps down the voltage from the batteries down to 5 volts. Here's the GPIO header, which powers all the peripherals. There's 2 sensors that are analog and go into the ADC. The other 2 sensors are I2C and send out digital signals. The OLED display communicates by I2C, so those 3 peripherals are an I2C bus. The SD card reader is SPI, and the buzzer and the RGB LED just go directly into GPIO pins and are pulled high, and they are visible and make noise. And then there's the Wi-Fi module on board that connects to the Lassonde service, and that's how you can view Lassonde remotely.